limits. And this is what we're working with. We're going to start with theorem 2.1, the limit of a constant. And this problem here is similar to what you're going to do in homework problem number 2. And it starts off with if some number c and x are real numbers and f of x gets some answer c out as a number for all x's, then and we can also say that for all a we have the limit of f of x as x approaches a, we get c out, we get a constant out. So these two are the same, keep that in mind. So we get an answer c out, and we also get a limit. So instead of L, right, we're specifically saying the limit L is the number c, the same as this. So we're going to choose delta to be equal to 1 for this problem. For all epsilon greater than 0, so we're saying that for delta, we're choosing delta is going to equal 1 for all epsilon greater than 0. So we have our absolute value of the function minus normally we have a function minus the limit and that's less than epsilon. But since the limit is c, we're putting here f of x minus c instead of f of x minus L, our limit. Whenever our difference between x and some number a, the limit that we're approaching, is less than delta. So we're going to substitute this 1 in for delta here. Okay. If the limit of f of x as x approaches a equal to some number c, and our function is also answer out as c, so the limit and the answer to our function are the same number, then we can substitute this f of x here. We can substitute, let me move this down, we can substitute c for this f of x here. And c is our limit from here. That's that number there. And so the difference between c and c, they go to 0. And so we have epsilon is greater than 0, and that's what we said up here. That's the same here. For x minus a is less than delta. So we've proven this proof here because these two, they come up to be the same. 0 is still less than epsilon. Okay, so that's theorem 2.1. Now let's look at theorem 2.2. If f of x equal to x for all x on the real numbers, the set of all real numbers, and a is in the set of all real numbers, so a is a real number, then so x is a real number and so is a real number. So we can say the limit for our function as x approaches a is a. So in other words, the a is substituted in for x, f of x, and for x, right? And we get that same number out. So for this, we're going to choose delta and x are equal to each other. Since f of x minus f of a since f of x and since f of x is x, and at the limit of f of a, f of x as x approaches a is a. So if f of x is x, then f of a is a. So f of x minus f of a is going to be x minus a. Then we can say that f of x minus f of a is less than epsilon. So in that case, since these two are equivalent, we can substitute these two for x minus a. And so x minus a is less than epsilon whenever x minus a is greater than 0 but less than, instead of delta here, we already said that delta and epsilon are equal, so we substituted epsilon in for delta. And so since these two are the same, excuse me, since these two are the same, then we've proven it. That is in fact a true statement. And so that is the conclusion of this video.